Imagine a world where we have an almost infinite source of energy that produces no harmful greenhouse gases. Could nuclear fusion be the answer to our future energy needs? The world is a bustling hub of energy, fueling the many activities that make up our daily lives. From the electricity that powers our homes, to the fuel that drives our transport, energy is an essential lifeblood of modern society. But as our population grows and our economies advance, our demand for energy continues to rise. By the middle of this century, it's projected that global energy consumption will double from what it is today. Simultaneously, the environmental impact of our current energy sources is becoming increasingly untenable. The burning of fossil fuels, such as coal, oil, and gas, is the largest single source of global greenhouse gas emissions. These emissions are the main driver of climate change, which threatens to disrupt ecosystems, economies, and societies around the globe. The search for a cleaner, more sustainable source of energy has never been more critical. Renewable energy sources like wind and solar power are part of the solution, but they can't meet all our energy needs due to their intermittent nature and the vast amounts of land they require. Enter nuclear fusion, a process that powers the sun and the stars. It holds the potential to provide an almost limitless supply of energy, with no carbon emissions, no long-lived radioactive waste, and virtually no risk of a catastrophic accident. Nuclear fusion could revolutionize our energy systems, providing a clean, safe, and abundant source of power for centuries to come. But achieving nuclear fusion is a complex and challenging task. It requires temperatures and pressures found at the core of the sun, and it has eluded scientists for decades. Yet recent advancements are bringing us closer to the reality of fusion power than ever before. So, could nuclear fusion be our much-needed solution? Let's delve into the fascinating world of nuclear fusion. Nuclear fusion, a term we often hear, but what does it really mean? Let's delve into this energy enigma and unravel the mystery. At its core, nuclear fusion is the process of combining or fusing two atomic nuclei to form a heavier nucleus. This is the same process that powers our sun and all other stars in the universe, creating a colossal amount of energy. The energy produced by fusion in a star's core keeps the star from collapsing under its own gravity. Now, you might be wondering, how does this fusion process actually work? Well, it's all about overcoming forces. Protons, which are positively charged particles in an atom's nucleus, naturally repel each other due to their like charges. However, if these protons can get close enough, a different force takes over, the strong nuclear force, which pulls the protons together, causing them to fuse and release energy. So if this process is happening in stars, why can't we just replicate it here on Earth? That's precisely what scientists have been striving to accomplish. The challenge lies in creating and maintaining the conditions necessary for fusion to occur. In stars, these conditions are naturally present due to the immense gravitational pressure and high temperatures. On Earth, we need to recreate these conditions artificially, which is no easy feat. Imagine having to create a force field strong enough to contain a mini-star, maintaining temperatures over 10 times hotter than the sun's core, and doing this in a controlled and sustained manner. That's essentially the challenge of harnessing nuclear fusion on Earth, but the potential payoff is huge. If we can successfully harness nuclear fusion, we'll have access to almost limitless clean energy. The fuel for fusion, isotopes of hydrogen, are abundantly available in seawater, and the process produces no long-lived radioactive waste, making it a potentially game-changing solution for our energy needs. In essence, nuclear fusion is like creating a mini-star right here on Earth. But how close are we really to achieving this? The road to viable nuclear fusion is not an easy one, so how far have we come? Well, it's been a journey of both triumphs and trials. Advancements in the field have been incremental, but every step forward brings us closer to making this dream a reality. From the early days of fusion research in the mid-20th century, scientists have been pushing the boundaries of what's possible. They've managed to recreate the conditions of the sun here on Earth, using devices called tokamaks. These machines confine hot plasma within magnetic fields to achieve the high temperatures and pressures needed for fusion reactions to occur. The largest and most ambitious of these projects is ITR, the International Thermonuclear Experimental Reactor, currently under construction in France. This multinational collaboration aims to create a sustainable fusion reaction, producing 10 times the amount of energy it consumes. But the road to fusion is not without its bumps. One of the biggest challenges in fusion research is maintaining the stability of the plasma. Too much instability can cause the plasma to touch the walls of the reactor, leading to a loss of confinement and a halt in the fusion process. Another hurdle is the immense heat produced by fusion reactions. Materials capable of withstanding such high temperatures while remaining operational are still being developed. And then there's the timeline. Predictions for when we'll have a working fusion reactor vary. Some are optimistic, suggesting a time frame of 30 to 40 years. Others are more cautious, pointing to the numerous technical challenges still to be overcome. Despite these challenges, progress continues. Each new discovery brings us one step closer to unlocking the vast potential of fusion energy. While we have made significant strides, there is still a long way to go. But what could this mean for humanity? As we continue down this road, the promise of a clean, virtually limitless source of energy looms ever closer. It's a goal worth striving for, a future worth fighting for. Scene script. Imagine the impact of having an almost infinite clean energy source. What would that world look like? Let's explore the potential landscape of a world powered by nuclear fusion. Harnessing the power of the stars, this technology could trigger a revolution in the energy sector unlike anything we've seen before. Picture a world where nations no longer vie for control over finite fossil fuel reserves. Instead, they tap into the abundant power of fusion, using hydrogen from seawater, an element so plentiful, it's virtually inexhaustible. A world where energy is not only abundant, but also affordable, potentially democratizing access to power and reducing inequalities. Envision cities illuminated not by the dark smog of pollution, but by the clean bright light of fusion energy. This is an energy source that doesn't produce harmful greenhouse gases or long-lived radioactive waste, making it a much kinder option for our environment. In a world grappling with climate change, fusion could be our much-needed lifeline. But the impact of fusion energy extends beyond the environment. It could supercharge scientific research and technological advancement. The immense temperatures and pressures required for fusion could lead to breakthroughs in materials science, plasma physics, and more. Fusion-powered spacecraft could even open up the cosmos for exploration and colonization, paving the way for a new era of space travel. Imagine the boost to economies around the world as new industries and jobs are created to support this burgeoning technology. Fusion energy could reshape global geopolitics, fostering cooperation over competition, as nations unite to harness this shared resource. Moreover, the security implications are profound. With energy independence, nations could reduce their reliance on volatile energy markets, leading to a more stable, secure world. The promise of nuclear fusion is indeed tantalizing, but it's not without its challenges. The road to fusion is fraught with technical hurdles and scientific unknowns. But if we can unlock this stellar secret, the rewards could be astronomical. A future powered by fusion energy is a future worth striving for. Like any groundbreaking technology, nuclear fusion has its own set of challenges. Nuclear fusion is a complex process, involving the creation of extreme conditions where hydrogen atoms can overcome their natural repulsion and fuse together. Achieving these conditions requires advanced technology that can generate and control temperatures over 20 million degrees Celsius, hotter than the core of the sun. But the technological hurdles are just the tip of the iceberg. There's also the economic challenge. The development of fusion technology requires significant investment. It's a high-risk, high-reward venture that not all are willing to bet on. Then, there are regulatory hurdles. Nuclear fusion involves manipulating atomic particles and, as such, falls under stringent regulatory scrutiny. It's a field that demands strict safety protocols and standards, which can slow progress and complicate research and development efforts. However, despite these challenges, the pursuit of nuclear fusion is far from stagnant. Around the globe, scientists and engineers are tirelessly working to make this potential game-changer a reality. In Europe, the International Thermonuclear Experimental Reactor, or ITER, is being built. It's a multinational project that aims to demonstrate the feasibility of fusion power. In the United States, private companies like Tri-Alpha Energy and Helion Energy are pioneering new approaches to fusion technology. And let's not forget about the scientists in Asia who are making notable strides in the field. These ongoing efforts reflect the optimism and determination of the scientific community. They are driven by the promise of nuclear fusion, a virtually limitless clean energy source that could revolutionize our world. Yes, the road to nuclear fusion is paved with challenges, but history has shown us that humanity thrives on overcoming the impossible. Despite the challenges, the quest for nuclear fusion continues. After all, the potential rewards are too great to ignore.